Welcome to the Landtamer Stream. It is Sunday, and we're concluding a good week of labbing by doing some more labs, of course. We're doing some DMVPN over VRFs, and I don't know what that was. 1 second, a little sound issue here. Okay, I think we're good. Yeah, so we had some issues learning DMVPN. I'm going to talk about that. I'm going to pull up the chat in case anybody wants to talk. By the way, this is a background. This wallpaper of the day is another aerial shot of the West End and Roatan Island, Honduras, future possible retirement spot. Yeah, so let's pull up the agenda for today. Well, this afternoon stream anyway, the morning/afternoon. Depending on where you are. But this is our agenda of what we're going to talk about. No shortcuts in the CCIE. This is what happens when you try to take shortcuts. And I'll tell you about that. But what happened to me was I tried to get ahead of myself and take it in doing labs. So I'll explain about DMVPN. If you watch any of my recent 1 second, guys. I've got something going on here with another screen. Okay, we're good. Yeah, if you watch some of my recent labs this week, you may have seen me struggle with some of the Phase 2, Phase 3 DMVPN labs. And I was analyzing this yesterday because I had an opportunity really to think about. Yesterday, I had an issue. I had to drive to a remote site. Had a switch fail. You may have seen me talk about that on. Oh, hey, good morning, Demetrios. How's it going, my friend? Where did my chat window go? Hey, there we go. Hey, I know it's morning for me. I don't know about you, Demetrios. Probably afternoon by now or evening. Over there in Europa. But yeah, good to have you, my friend. Good to have you here on the stream. Yeah, I want to talk a little about what happened yesterday. I was unable to stream yesterday because although I was not on call, I was the closest person to one of our sites where we got an alert that one of the switches had gone down. Actually, I think it was scheduled for maintenance. There was an issue that had been syslogged on the switch early in the week, and so it had been scheduled to perform a reboot. TAC had said, okay, this is likely just a temporary issue, just restart it. So, you know, our remote support team did a restart last night, and then they informed me at 2 a.m. that, hey, the switch did not come back up. And we don't have console access to the switch. It's in a closet, you know, that just does not have console access. So I had to go out there and drive. You know, it's not really even 2 hours away, but drove out there, and before I did, though, I loaded up on some videos, I&E videos, to get caught up. And as I'm going through these I&E videos, these are the videos I should have watched earlier before trying to actually do the labs. And I was analyzing a little bit yesterday and thinking, man, these videos are pretty good, actually. And the ones I'm talking about are I&E. If you have the I&E material, if you purchased it, you know there is and I put that as in past because I finished these. That's how I sort out all the I&E videos that I watch. But, you know, I did the DMVPN section, routing protocols, Phase 2, Phase 2, Phase 3. And I actually finished watching these videos. I made the mistake of watching these videos prior to doing the labs, which, big mistake, I realized. And normally I don't do that. I don't know why I did it this time. Maybe I felt a little pressure to be on stream and to have something to lab, but that's not an excuse because I've always said that if I'm not prepared, you know, I try to lab every night during the week and on the weekends, except for Friday, sometimes Saturday, but I always try to have something to lab. But one of the mistakes I've made is, in this particular case, is I wasn't ready to lab this stuff yet. I had not watched the videos. I had not read the material, but I went ahead and did it anyway. I tried to take a shortcut. And every time I've tried to do that in the CCIE study program, it has bit me in the behind. So, and I knew better, but I did it anyway. And sometimes it's just during the week. This doesn't happen to me so much during the weekend, but during the week I get a little rushed. I had a lot going on this week. I get a little pressured, and I want to be present on stream, but that's not an excuse, like I said, because what I've told myself, a commitment I made to myself is, yes, I want to stream every night. I should be labbing every night, something, even if it's a short lab. But if I'm not ready to proceed forward in the workbook, I can always do a review lab. But I got anxious to get through this material. Part of it, too, is I want to catch up. There's someone in the community there trying to catch up with Tony. I'd love to get to where he's at on multicast so we could kind of lab together. So that was part of it. But again, you cannot rush. You cannot take shortcuts trying to get your CCIE. And Brian McGann has said this in his videos. Other people have said it in their blogs. And it is so true. As soon as you do it, you end up wasting your time. You'll see me spinning my wheels in those labs. Now, partially to my credit, it was interesting to watch in one of these videos. I think it was the last one in the series of DMVPN, where Brian McGann actually had the same error I did. The tunnel would not come up, and it was a software issue. He had to actually reboot. I think it was actually a configuration error. But I felt better about that, at least, because I struggled a few times during last week where the DMVPN, the tunnels would not come up. And sometimes it was my own error, but at least once I think it was a software bug or issue. And Brian said the same thing. And he said sometimes you get these errors and the only solution is to shut down the tunnel and bring it back up. And sometimes that doesn't even work, especially when you're doing crypto. And sometimes he even says that you have to restart the router. So I felt better. Like, all right, it's not just me. So that felt good. And I need to do one quick thing over here on another screen. I'm managing 4 screens right now today, folks. So, okay, cool. So anyway, that's my point. Is there are no shortcuts in the CCIE, and if you've been doing this a while, you should be able to catch yourself. At least I'm getting better at putting on the brakes and saying, okay, I feel myself trying to go a little too fast and take a shortcut here. Stop taking the shortcut. Turn around. Take your time. It will pay off in the long run if you understand the material, at least to a basic level, before you start trying to lab. And so yeah, I've learned. But with that in mind, I did have a lot of time yesterday, even though I felt bad because I really wanted to lab. In fact, I was listening to these videos. I'm like, oh man, I can't just can't wait to get back in and try some of this stuff. But I had a lot of time to cover videos yesterday, which is great, on the drive, etc. And what I'm at odds with here is if you look at the workbook, and again, I'm not going to pull up the workbook. I'm going to talk a little bit here about what we're doing next, because this is the last lab today for DMVPN. I decided I don't really need to, I didn't want to show that checklist. So this is my checklist. These are INE labs. And you will notice here, we got RIP, EIGRP. This takes a second to load, guys. This is working. This is a large sheet here, and it's doing calculations. But we get past RIP, EIGRP, OSPF, and we get into MPLS and IPsec VPN. So this is the last lab. But notice the next lab here is multicast. Okay, great. That's great. But there's a section of videos. That's IPsec VPN. I actually finished that today too. There's one last video there. There's a section of videos on convergence optimization. 5 of them. And this is what I really want to do next. But the thing is, there are no labs here for that. There is no convergence optimization here. that I've seen. If someone knows of one, please correct me. But you know, we have system management, IP services. Let me just search actually Convergence. Yeah. There's a few here and there on Convergence timers, and maybe that's the point. They're spread out. But this is really pertinent to me. There's one particular site and issue that I'm working on a Convergence problem right now. So I really want to lab this next, but there's no I&E labs in this workbook anyway. So I may have to kind of reach out to the community. And my goal here is to, with BGP, to detect a failure quickly and to propagate the change, the convergence quickly. I won't be able to do that if we're going right into multicast. So we'll see. I may just focus on finishing those videos before I do multicast, and then maybe we'll come up with some of our own labs, because I actually need to lab a situation in my work environment right now that has to do with convergence and BGP. So anyway, that's what's upcoming, folks. But we still have one DMVPN lab to go. That's VRF-aware. So we're going to do that here shortly. DMVPN. Okay, meat chunks. Yeah. So Demetrius, my friend here in the stream, he posted this link in the Discord channel. If you're not on Discord, folks, check out the Discord channel. It's posted below. You cannot miss a Narbik seminar. I mean, one word, Narbik. That's all we need to say. I want to get a t-shirt that says Narbik. It'd be great. But anyway, there's a free live seminar. You only have to register, of course, with Cisco Learning Network. You have to log in to get access to this. But on this page, there's a new seminar that's posted for Narbik coming up next Thursday, I want to say. And of course, I attended the first one live. Usually they're available later as video on demand too, which is great. But you don't want to miss this, so be sure to sign up for that, and we'll see you in that seminar. It is during my working hours. I know, depending on where you are, it may not be. It may be 3 in the morning. I don't know. You will have video on demand. For me, it's during my working hours, so I may play it in the background, but I may not be able to really pay attention. I may have to later watch it on demand. We may be using this today for our DMVPN lab. This is from Packetlife. He's got an example of multiple DMVPNs over a single hub. We may be using that as a reference configuration for today's lab. And then CCIE by 30 had another nice little blog about Cisco Discovery protocols. So yeah, good stuff. And let's get into our lab today, VRF-aware DMVPNs. So let's pull up our requirements. I'm loving this stuff, by the way, DMVPN. You know, I'm really getting into the areas of CCIE study where I can make some impact where I'm at my job, you know. So I'm looking forward to these next areas. You know, DMVPN has been good. Tunneling is great as well. But anyway, here's our requirements. Here are our configurations that we're going to use, a little scratch pad. And let's see here. Let's pull up the requirements from the workbook. Standard disclaimer here, guys. This is not a lab I designed. This is in the I&E routing switching V5 workbook, V5.1 workbook, I believe. If you want to do this lab yourself, definitely check out their workbook link below. It is $2.99 with plus discounts usually. So, but again, I'm just vlogging here my experience, but and I won't be showing this, you know, of course, the workbook on the screen. But we're just going to sort of alliterate here what our requirements are for this lab and show you our struggle. VRF-aware DMVPN. And we're going to create some VRFs. So we haven't done this in a little while. So this will be good practice as well. So router 5, 6, and 9. We want a VRF called underlay transport. We're going to use 1:1 as a route distinguisher. Simple enough. On R5, it's going to be going towards R4. R6's links to R1 and R7. R9's link to R7. And on router 6, we're going to do a loop back with 6.6.6. The loop back 6.6.6.6 assigned to VRF. And we're going to configure R5, okay. Static route. Static default route. Okay, configure R5 with a static default route pointing towards the VRF to R4. Interesting, okay. And we're going to do the same thing. Well, router 9, static default route to the VRF going to router 7. It says static route in the VRF. Okay. And then, okay, so we're going to have some static routing. This is interesting. Let's go ahead and draw this out because this is getting interesting here. And I'd pulled up the INE topology page, but I think it's going to be a good idea to actually grab my drawing. So let's pull that stuff and draw this stuff out here. All right, topology routing. There we go. So again, this is just my own, I did my own Visio drawing here of the same INE topology to suit my own needs. And we're going to do a little drawing here. So we've got, again, a VRF name on router 5. Let's see, router 5, router 6, and router 9. Well, that's interesting. So it looks like we might be doing a sort of cloud here, maybe. So VRF, we got, and on router 6, the VRF is going to be, how do we denote this? VRF going that way. Okay. So he's going to, router 6, the VRF is going towards router 1 and router 7. On router 5, it's going towards, and I don't know why I'm drawing this to denote a VRF. For lack of a better way to, yeah, it kind of brings up something too. In reference designs, what is your go-to for like a standard drawing? I'm still kind of looking for a good, my own style. You know how you kind of develop your own style of drawing and your own set of symbols? Some of these symbols are new for me. So I already have a drawing style. I have a drawing template, a Visio template I use that I start for everything. It's part of it is here, right? I use it also for work, but I've removed, of course, some of the things that are work related. But this is generally my style here. So I like to use, obviously, different colors. I like to use these little boxes for interfaces. VRFs is new. So how do you denote VRFs? I'd love to find a good sort of reference drawing on that. But this is our topology here. So we got VRFs here. And on router 9, we've got, we're going to do a looks like a good size little topology here. Okay, so these are our VRFs. And create a new loop back on router 6. Let's see. All right, so we're going to do a loop back here. I should do that a different color, right, or something. And this is going to be 6.6.6.6, that's 32, right? Whoa, that's pretty big. So let's make that about 20. And he will go up here. So this will, let's see, this will be assigned to the VRF as well. So R5 will have a static route pointing this way. Okay, so let's draw that. We'll say IP route 00. To the VRF. Are we going to have that here on router 5? Yeah, that's good enough. And where else? And we're going to have it on router 9, okay? Makes sense? Kind of shaping up to be a client here with remote sites, sort of, right? We got a router 9, we got a router 5, and maybe we've got a hub here. So maybe this is your data center. Router 6 is in your data center. And then you've got a cloud here. And you've got a cloud here. And these are your remote sites. It's kind of what that's shaping up to be, at least in my mind. Now let's look at our BGP configuration. Router 1 and router 4 are in AS 100. Interesting. So let's do this. And select a different color here. AS 100. I don't like how that's turning out, so. AS 100, interesting. I have not looked at this lab beforehand, so we're all kind of discovering this at the same time here. Router 3 and 7 are in AS 200. Okay, so let's turn this around. Okay, AS 200. All good. And router 6 is in AS 6. This is looking a little bit, now this is different. I was thinking this looks a little bit like the INE BGP topology. You know, before I pulled up just the basic INE map. But let's go to that. So if you go to their topology page, which is linked below, you know, they have a basic set of diagrams. I don't know if y'all ever looked at this. I'm sure you have. So we have a example. This is the physical topology, I think, that they would normally use. Looks a little bit different for the viral, right? And then this is advanced technology with addressing. And this is essentially the diagram that I pulled up earlier that I have back here, right? And this is without addressing. And this is your BGP diagram. So this we've used a lot in the BGP section of the lab. Okay. And I was thinking, this is starting to look, we've got AS 100, 200, but you know what? This is, what we're doing now is nothing like what this is. So, all right, I just wanted to check. This is AS 6. And router and 1 and 4 should appear iBGP, 1 and 4, of course. 3 and 7, iBGP. Router 1 and 3 should appear eBGP. Okay, so we're going to have... It's weird that when I click on that, that's what I want, and it's already selected, it switches off to something else. I have to remember that. So this is going to be eBGP. And we'll get a little fancy here. All right. Let's see, router 1 and 4. 3 and 7, 1 and 3. Wait a second. It says router 1 and 4 should be iBGP. Router 3 and 7 should be iBGP, right? And routers 1 and 3 should be eBGP. And then router 6 should pair with eBGP with router... Ooh, this is going to be BFD, which I have not used. Okay, so it looks like maybe I should have already seen the videos. But, oh man, oh well. That's the shortcoming of the ID material, I tell you folks, is... You know what would be really nice, INE, if you're listening, is if you would take the workbook, and again, I'm not going to show the whole workbook here, just maybe a little portion. If you would take the workbook and interpose the prerequisite videos you need to watch first, that would be really awesome. Because it looks like we're going to be out of order again. But anyway, we'll do the best we can here. We'll learn. That's what we're here to do, right? We're here to learn. So we're going to use router 6 is going to pair with... Okay, I'm copying the wrong thing here. I want to select this, copy, paste, good. It is going to pair with router 7 and router 1, and we're supposed to use BFD here, bidirectional forwarding detection. Never configured it before in my life. We're going to figure out how. Okay, let's mark that too somehow. So let's do BFD. So we're going to have BFD here and BFD here. Cool. I like this. This is very practical for me. All right, router 4 should advertise the link to router 5 in BGP. Router 4 should advertise a link to router 5 into BGP. Okay, we're not going to put that on the drawing. Router 6 should advertise this loop back into BGP. And router 7 should advertise the link to router 9 into BGP. All right, we'll put it on here. So these are basically the routes that we want to advertise. GI0, we're going to say 151.45.0. And what do we say? This one? Yeah. 151.79.0. All right, so these are the routes we want to advertise here. So we're going to, I guess, check some sort of reachability. So look at router 6. Router 6, he's going to have this route to router 9's segment. And he's also going to have potentially a path going this way. If our policy allows, yeah, so we want, this should be advertised by router 7 and it should be advertised by router 3 as well, eBGP. But of course it should take this route, just looking without any other policy, because we got, if we go by AS path, we got AS200, AS6. This will be AS200, AS100, AS6, right? So this will be your preferred path, which is good. In a similar scenario this way, right? Okay. Now, we are going to create a DMVPN phase 3 network between 5, 6, and 9 as follows. 5 and 9 are the DMVPN spokes and should source a tunnel from their VRF-enabled interfaces. 5 and 9 are DMV. Router 6 is the hub. Okay. So what we have here is we're going to draw these tunnels. And it's kind of going from here Yeah, this is going to be coming from the loopback to his VRF. Okay, so we're going to have one tunnel here. Too many colors, too many colors. Let's make this green. And we're going to have another tunnel here. Okay, nice. This is a good size lab. This is probably not going to be done before lunch. I will say that. So this will probably be a two-part stream. All right, create a DMVPN phase 3 network between 5, 6, and 9. All right, good, good, good. And then we want to do on top of that, we're going to do IGP routing. All right, interesting. So our routing is going to be, let's draw a little EIGRP cloud here. So we're going to have let's make this a solid, right? And this will be EIGRP 100. Let's match this. Yeah. Wow. Okay. Getting intense, guys. Getting intense. Very intense. All right. EIGRP 100 here. And EIGRP 100 here. Well, that turned out good that we used blue, right? Oh, for the VRFs. All right, EIGRP 100, EIGRP 100, EIGRP 100 here. Let's do a little circle up there. Let's try. Okay, it's getting a little crowded, I know, but it's okay. AS6 and EIGRP 100. Man, I feel like this would be similar to what you might see in the lab. This is a nice little extensive configuration, at least for me. Okay, and then we are also going to do, this is going to be in multi-AF mode, by the way. And we're going to do IPsec. So when complete, the goal is to ensure that router 5, 6, and 9 can reach each other's loopback networks over the DMVPN network, and that spoke-to-spoke traffic does not transit the hub. We also want to ensure spoke-to-spoke reachability is maintained if router 6 loses its peerings to either of these. Good. Okay, so let's continue to, I feel like the first part of this, guy, is going to be, the stream is going to be just the setup, right? That's okay. So let's write the rest of this out. Now that we have our drawing. Okay, loopback, static route. Okay, BGP. I'm going to call this section the VRFs. Okay, then we got our BGP section. Yeah, this is going to be a long lab, which is good. I like it. AS100 is routers 1 and router 4. AS200, router 3, router 7. AS6, none other than router 6. IBGP will be routers 1 and router 4. router 3 and router 7. eBGP will be router 1 and router 3. Router 6 and router 1. And we want to use BFD there. Router 6 and router 7. Okay. Then R4, advertise link to router 5 into BGP. This is all BGP, right? And router 6, advertise loopback. And router 7, advertise R9 link. Now, DMVPN section. Okay, that is going to be, well, a swig of coffee here. All right, DMVPN, router 6 is a hub. Hub sourced from new loopback. That's easier than typing 6.6.6.6.32. Router 5 are the spokes sourced from VRF. And this is the new part, right? For me, the new part here, well, a couple of new things. We're doing DMVPN over VRF. That's one thing new. We're doing BFD. That's new. And 3, we're combining EIGRP, DMVPN, and BGP. That's new for me. So a lot of new stuff in this one, which is great. It's awesome. Use IP addressing, what we're used to, which is 1510.r/24. NHRP network ID of 1. NHRP authentication is what we're used to. NHRP auth. Tunnel key of 2. And we do want phase 3. Yeah, because we want spoke to spoke. We want to use NHRP redirect and shortcuts. Okay. Ensure spokes can send multicast traffic to the hub and vice versa. Okay, we want to perform fragmentation prior to encryption. Okay, then we have our EIGRP, which is our IGP, right? Oh, sorry, skipped a section. IPsec. Yeah, we have an IPsec section as well. Actually, it does list EIGRP next. Doesn't mean we have to do it in that order. In fact, they may be purposefully trying to kind of change up the order on us here. Make us think. We want to use multi-AF mode, AS100, on DMVPN interfaces. PSK is going to be DMVPN_PSK. We're used to doing that. Oh, I jumped ahead. Yeah, I'm not sure. These are very close together here in the workbook. Okay, advertise L0 prefixes into EIGRP, R6 will send only a default route. Okay. Okay. Now, crypto. ISA KMP policy using PSK DMVPN underscore PSK, AES-128, SHA-256, group 16. I could almost type this right now. Use a single VRF-aware wildcard. I don't know what that means. PSK for all DMVPN peers. VRF-aware wildcard. Okay, I guess I know, I understand. We don't want to inadvertently form a tunnel with someone who's not communicating through a VRF interface. So I'm sure there's a way to do that. We'll figure it out. And then IPsec profile is going to be DMVPN underscore profile, AES-256, SHA-512. And we want to use ESP transport mode to save in cap overhead. Yep, standard stuff. Okay, when complete, verification. We want to be able to, that R5, router 6, and router 9 can reach each other's loopbacks over DMVPN network specifically. And router 5, router 9, will not transit the hub. In other words, we can form a spoke-to-spoke tunnel between 5 and 9, right? What else? Okay, we want to ensure reachability is maintained if R6 loses peerings with AS100 or AS200. Okay, wow. A lot of stuff here to pack. But, you know, we've done all this before, except, like I said, the VRF-aware DMVPN configuration and BFD, which, as I understand, is not much to that, right? At least in terms of lines of configuration. So there we have it, folks. And let's see, how long have we been streaming now? Not very long. Okay, that's something that's kind of hard for me to tell. I think there's a command we can do in chat. Let me see if the bot. Yeah, guys, I gotta get my chat chat game going here. There is a mod tools. Yeah, I gotta learn this stuff. So if we could get a bot here in the chat in Twitch, we can set up some commands so that you can type in uptime, you can type in lab, etc. Anybody could type that in and it would show that on the screen. So that's something that we want to, yeah, it's something we got to work on. So yeah, we'll figure that out. So that is on the to-do list here. A bot setup. What are some commands we want? We want to do uptime. That's one I've seen used a lot. This tells you how long you've been streaming, or this person has been streaming. We want to do lab, maybe. Let's see, is it uptime? Uptime exclamation. No, okay, yeah. I don't have any of those enabled, I think. I have to enable the bot. So yeah, uptime, we want lab. Like, which lab am I working on? What would be some other useful commands? If you can think of any, just drop them in the chat or in Discord. But we will work on that. But I think I can look over, because in YouTube it was very easy to find out how long I'd been streaming. I'm going to look on my dashboard over here. Yeah, I can see number of viewers. I can see views. Oh, there's a time. Okay, okay, 45 minutes. Good. All right, so that's pretty good for a setup. But again, it is around lunchtime, and I didn't know how long this lab was going to take. But we're going to come back. Let's just review again the setup. And what we'll do is we'll come back after lunch and actually do the config. So we've got EdgeRP is going to be, so if we think about this, for the DMVPN to work, we're going to have our internet-facing addresses, right? So in this case, router 9, if he wants to form a tunnel, then this is going to be based on tunnel reachability. Is going to be based on the physical address of this 155.170.90. So this interface will be advertised into BGP. And of course, if router 7, if this link goes down, we're done. That's our only way out, right? But what they want to test is BFD on this leg, which is, part of essentially a cloud here that router 9 doesn't really care about. That's why we've got a VRF, because maybe we've got a client here who has resources that we're hosting out of a central office. And then we're hosting networking services out of this remote office, right? So all router 9 cares about is that he has reachability to the quote-unquote internet. And that is this interface here. But for any of this to work, our underlay has to have reachability to router 9's link to the internet. So this is 155.170.90. That's why this is so important that it be reachable by router 5 and router 6. And so that's why we have, of course, redundant links here, which is good. We notice that our redundant link really comes by way of, we have this AS here, this AS here, but they are linked together. So AS 100 and 200 are linked together. That's what brings in our redundancy, so that these are the preferred paths, but if we drop either of these preferred paths, we can still reach router 9. Router 5 can still reach router 9's underlay address by going through AS 100 and AS 200, right? So this is a really good, simple lab to kind of illustrate this concept of the underlay versus the overlay. So we've got, though, a couple layers here. And if we, again, I'm just kind of doing a little analysis before we actually get into the configuration, which will be lab session post-lunch. But if you think about it, there's going to be a lot of encapsulation going on here, I think. Because we're going to have, let's say for traffic for router 5's loopback 0 to router 9's loopback 0. Think about all that this will go through, right? So let's walk the packet a little bit. When this is all done, router 5 will have a default route. So yeah, let's say router 5's loopback wants to reach router 9's loopback. He's going to have a default route to a VRF interface. So the CEF is going to say your next hop is the VRF. Okay. And he will know about, I'm trying to think. Now this is interesting, right? Because there's going to be a default route through the VRF, but he's not going to really use a default route, right? Because once these tunnels are up, we will learn through EIGRP. So if I do a show IP route here, I should have a default route, but I should also have a more specific route to router 9's loopback in the EIGRP routing table. Eventually, too, I will also have it in, it won't use this though, but this will be the most specific route. There will be a shortcut. There will be, if I do a show IP NHRP, when everything is nailed up, we will have an NHRP entry and we will have a tunnel. NBMA address will be the 151.40, actually, yeah, 151. Let me think about this. What will be the NBMA? Yeah. It'll be 151.45.5, and the mapped address will be 151.0.6. Yeah, this will be the hub. But we will also have 151.0.9. Wait a second. We're going to source this. Yeah, that's right. Wait, let's go back and see. Okay, loopback is assigned to a VRF here. And that's interesting because this loopback is throwing me off a little bit. I'm accustomed to using a tunnel interface. And then the loopback is generally not a member of a VRF, but it will be in this case. All right, that's fine. All right, but let's not get ahead of ourselves here. Strictly in terms of the DMVPN, all our tunnel interfaces are going to be on this subnet. And again, the spokes will be sourced from the VRF interface. And the VRF are assigned to this link, right? Okay. So yeah, this is what our map will look like. And we'll be able to actually do show IP route in HRP. And we should see entries in there as well in HRP routes. Okay. So we will have a route here in EIGRP, and the next hop address here but wait a second. We will not have this route here. And the reason why is because the hub down this link is it will only advertise a default route. It is not going to advertise a more specific route. That's right. So we will have a gateway of last resort. And what will that be? R6 will only send a default route. It'll be using the DMVPN interface. Okay. So our gateway of last resort will be 151.0.6. However, again, we will have an NHRP shortcut. We will have an NHRP shortcut to 150.1.9.9. I don't remember what the next hop will be there. I think it's going to be our 5.1.0.6. Or no, sorry. Yeah. All right, that sounds right. So we're going to learn a default route to router 6. And on router 5, I do a show IP route NHRP. I should have a shortcut here that will be learned from NHRP redirect and NHRP shortcut to this. And I'll have a mapping here. I will also have show crypto ISA-KMP. Now this will be new as well because we're using a VRF. So we should see something a little different here. And I saw that in a blog as well. So, all right, that's true. Because we're going to actually form a tunnel. Let's see, our peer here will be, who is our peer? We should be using the tunnel interface. So I think I'm going to have I'll have 2 tunnels. But I will have one to router 9 because we're going to have a spoke-to-spoke. By this time, we should have a spoke-to-spoke tunnel. So I should be able to see show crypto ISA-KMP SA, and we'll have a peer 151.0.9. We'll also have a peer to the hub. And I should be able to do this as well. Yeah. Okay. And I should have 2 crypto tunnels running. Okay. Good deal. Now this is interesting. If we get a default route, if we assign a static route, router 5 will want a static default route in router 4 in VRF towards router 4. So really we will use the static route before we use the EIGRP route. But it's going to, it will essentially do the same thing. All right, this is going to be interesting. All right, so when we send the packet, if we do a trace route, it should just go to a trace route to 150.1.9.9. It should just go to 155.1.0.9 and then resolve there. All right. And in BGP, let's just ensure, yeah, so in BGP, if we're advertising this link and this link, as long as we have reachability, we have a triangle here, we should be able to form our tunnels. All right, good deal. Well, folks, I think I'm going to leave it there. I'm going to grab some lunch, take a little break, and then we're going to come back and continue the same stream. I'm going to leave everything running. Thanks so much for tuning in. Appreciate you coming in the Land Tamer stream, and we'll be back after lunch again to knock out this lab and actually do the configuration and the validation. That's going to be fun. Looking forward to it. There's a lot more than involved than I thought it was going to be. So don't go too far, folks. I know you probably just you might be studying yourself, playing this in the background. Yeah, we'll see you very shortly. Thanks again for hanging out.